Can you solve this trig integral? So here we have the integral of 1 over the absolute value of the square root of x squared minus a squared. What I'm going to do, I'm going to go ahead and set x equal to a secant of theta. So the derivative dx is going to be a secant of theta tangent of theta, d theta. So if we go ahead and rewrite the integral, that's going to be, well, dx is on top here, so that's going to be our a secant of theta tangent of theta, d theta. Our x is now an a secant of theta, okay, because we have x down here and up here. And our square root term is now going to be an a squared secant squared of theta minus a squared. Now recall that the sine squared of theta plus the cosine squared of theta is equal to 1. If we divide everything by cosine squared of theta, we get that the tangent squared of theta plus 1 is equal to secant squared of theta, which means from our square root value, we can rewrite this guy as secant squared theta minus 1, and that's going to be given by our tangent squared by subtracting 1. We have a squared tangent squared of theta, and this is going to cancel out to just a tangent of theta. So let's rewrite our integral as a secant of theta, tangent of theta d theta, divided by absolute value of a secant of theta times another a tangent of theta. And take a look. So our secant theta cancels out, our tangent of theta cancels out, and one of our a's cancel out. So the final integral can be written as 1 over the absolute value of a d theta. That's just going to be equal to the 1 over the absolute value of a times theta. Where let's go back here and rewrite our theta in terms of x. So that's going to be x over a is equal to secant of theta, or that our theta is equal to the inverse secant of x over a. Our final answer is 1 over the absolute value of a times the inverse secant of x over a plus c. I'm Dr. Andrew. Follow for more practice problems.